Hello, welcome to another episode of Undercooled. Today, Tim and I are going to talk about grading. Why? Because we just graded our class from the end of the term, and it's foremost on our minds. So why don't we start by talking about what grading is, why it exists, and maybe some of the problems we've identified. So we'll start with what's wrong with traditional grading, and let's start with curving. So Tim, what do you think about curves?
I think they're very statistically interesting, and they reflect a few assumptions and biases in our grading system. First is this idea that there should even be like a Gaussian distribution in our populations that we're working with. And like a lot of these assumptions about grading, there's a nugget of truth to it. If you looked at the entire nation, there'd probably be something pretty close to a normal distribution of, proficiency in lots of different areas. But at a university, we're performing this biased selection from a certain subset of the population to try to get the kind of people that we want to get. So believing that there should be an underlying normal distribution is already quite a flawed model. We tend to have a much more skewed distribution with the students that we have because we're selecting who we admit. Some of those selection criteria, actually, that's another episode entirely. We can talk about admissions another day. But we don't have a Gaussian distribution to begin with, so why would you try to enforce one? I think curving is pretty silly in that sense.
Yet we're always told that you should fit your distribution to a bell curve, which is a Gaussian distribution, of course. And that's the standard way that most faculty just approach it. And it's a shame because it's really flawed thinking, like you just pointed out.
And there's another problem there, which is to a lot of students, this conveys a very competitive, anti-collaborative mindset, right? If they're going to be stuck onto a curve, then they have to outcompete their classmates in order to get a grade, which maybe they should or should not actually care about, but intrinsically a lot of them do. And as soon as you throw away the curve, you can get to a space where everyone can succeed and everyone can help each other achieve at a higher level to actually meet and hopefully exceed your expectations for the course.
Yeah, that's so true. Whoever said that only 10% of the class should get A's? What does that mean? If you take teaching seriously, like I think we do, you want everybody to be able to get an A, but you have to have the bar pretty high so that everybody actually earns an A. But our goal should be to get everybody there. Why have an arbitrary number? That makes absolutely no sense. And another thing that makes absolutely no sense is why we're so focused on teaching grading with a 0 to 100 scale, as if we have the precision to say anything about that. So if you think about it, when we grade on a 0 to 100 scale, we normally look at the standard grading, which says you need a 93% to get an A, a 90% to get an A minus, an 87% to get a B plus, etc. Why do we have those numbers? And when we do it like that, what happens is the entire class gets compressed between usually 75 and 100. And then we look at all the scores, especially in a large class, and we look for natural breaks because we're so omniscient, about what these things mean. And we know that this moves people to the right area. So we sit there and we look at grades and we look at the boundaries when we do our final grades, because we usually never publish these because then the students will scream at us. And we look and see, well, this person had a 89.95. And okay, you go, well, that's pretty close to a 90. Let's give them a 90. Except you realize in your class of 150 students that you've got 10 students, 4 of which have 89.95, and then just below that, you have 89.89. And you go, that's a big jump. But think about that. That is 89.95 versus 89.99 even. That is 0.04%. So the fraction is, 0.0004. How in our wildest dreams do we feel that that is significant? If we were to put error bars on this and think thoughtfully of what those error bars mean, probably we can only measure learning through exams and grades and stuff like that to, at best, plus or minus 10%, which is a lot bigger than 0.04%.
Yeah, there's a great irony there that, especially in a lab context, I'm always mentioning to students the importance of significant figures and thinking about the precision of your measurement and how the number of digits you use conveys the intrinsic precision of the tools that you're using. And 4 significant figures on a grade, like that's that's borderline meaningless. I could be convinced we have 2 sig figs, as you said, to order of 10% error. Yeah, that's actually pretty achievable, but
and hard to do, but possible. And but if we were going to grade ourselves on that kind of effort, we'd probably fail. And yet this is done in just about every class all over the world, and it's absurd, and it's not right. And so unless we can find a way to magically improve the precision of our measurement of learning, which maybe can be done. I mean, you can have precise measurements that are good down to 10 to the minus 7 delta E over E, or however you want to measure it. Look at the LIGO project, measuring gravitational waves. Okay. That was the hero project of improving precision. Unbelievable what they did. But, that took billions of dollars, and it was in an area where you actually could make those measurements and could improve the precision. I'd argue it's a lot harder to measure learning than it is to measure gravitational fields. And so why are we even doing it? So the simplest thing, of course, to do is not grade on a 0 to 100 scale, but something like 0 to 10, or even 0, 1, and 2, or a 5-point scale, or something like that, where the data is a more meaningful reflection of the actual precision that we're trying to measure. And so, but it still comes back to, how do we measure learning? And that's a deep subject. And I'd argue that is the hardest problem in education, is how do you measure learning? And I wish more people studied it, but they really don't. They just keep giving tests. And tests are a problem. Maybe you can talk about the problem with exams.
Oh, goodness. I first have to come from the research perspective, having done education research for enough years, that there is this gap between measuring learning in a rigorous research context versus what you have to do to survive as a teacher with hundreds of students in one semester. Developing a tool to precisely and reliably and validly measure student learning in one small topic area is a years-long effort, and that's not something that any of us have the luxury of time to do when we're just trying to get through our day and hopefully try to make sure that our students are learning something, rather than spending all of our time developing measurement tools. These measurements can be done, but I don't think it's practical to expect most practicing teachers to get into so much of the minutia of the psychometrics and the statistics and the validation procedures to say, yes, I'm actually measuring learning with this test. That's just not something we can practically do. So instead, you have to ask, how should we assess our students? What can we do as regular practitioners of this craft of teaching to say, I think I have a gauge, a certain level of understanding of which of my students have learned how much.
So the other problem is that almost all exams are focused on having a student demonstrate a certain level of knowledge on the day and time of that exam. And very little thought usually goes into the idea of retention. And this is famously borne out with Father Guido Sarducci's little comedy skit, The 5-Minute University. If none of you out there have ever seen that, just type into Google 5-Minute University or in YouTube and watch it. And he makes the point that, in 5 minutes, he can teach students what the average college graduate remembers 5 years after they leave college. And sadly, it's kind of true. And there's a large body of educational research that bears this out, that by giving students exams that are largely factual recall and retrieval, has caused generations of students, myself included, headed to the library 2 days before the exam to cram like crazy, to remember all the things that I might be tested on. Then I go and do a data dump on the test. I do really well, but they show that even 2 hours later, the students couldn't even do 50% retrieval of what they just did. And 2 months later, it's down to 20% or some crazy low number. And so that's the whole point of Father Guido Sarducci's little skit. And why don't we think about retention? Retention's what really matters. Now, in some fields where it's conceptually based, we can think about concepts. And if you can understand a concept, the chances are you'll retain that understanding much longer than just memorization. And so the physics community has come up with concept tests, which is really an excellent way to do that. But it's not so easy to translate that to other fields, because most of the concepts in material science, for instance, are really chemistry concepts or physics concepts. And we don't test those. We try to test the ability to use those concepts in the context of material science to be able to answer a question. Like earlier, we were just playing around with the new voice model for ChatGPT. And Tim, you asked it about Martensite. What is it? Mm-hmm. And ChatGPT was confused. It just said, it's an interesting phase, but I don't really see it on any of the phase diagrams, so I'm not quite sure what it is. And so ChatGPT, just scrubbing the internet, didn't get that it's a metastable phase. And you don't see metastable phases on equilibrium phase diagrams, and that's the whole point. So there's an underlying concept there. And so that's why ChatGPT didn't get it, because it doesn't really understand anything. It just repeats things. So giving exams is a dangerous way, in my opinion, to assess learning.
But there is one type of exam that's fantastic for actually understanding whether your students know something.
That's right, but that's not a written exam, is it?
No, yeah, I think you know where I'm going with this.
Go ahead.
Oral exams can be so powerful, both on the student side and on the teacher side. This ability to interact with someone in real time, to ask them questions, to give them hints, to see exactly where in the process of working out a problem in real time, where they get stuck, where they have moments of insight. That can be very powerful for revealing learning in our students. And it's the original adaptive testing, right? Yeah. The student is crushing it. You make the question harder. You see how far they can get. The student is struggling. You back off and you give them support, and you see what you can help them with collaboratively. And
that's right.
We're trying to develop all of this technology to replicate that experience. But either way, the oral exam, as good as it is not very scalable. If you got a class of 100 students, how are you going to have 100 half-hour-long conversations with all of the individual people in your class?
And that's the key point. Some people say, oh, you only have to give a 10-minute oral exam and you can learn everything. I'm not sure I agree with that. And then they say, well, to grade somebody's paper takes about 10 minutes, so it should be scalable. But I think you said the key thing. It kind of takes more like a half an hour for every student because, we all of us who went and got PhDs, most of us had a PhD defense, which is an oral exam. And that takes at least an hour, sometimes 2 hours. But that's a big body of work. And I'll never forget, I was a math major as an undergrad, and I had a really interesting professor who he was in the National Academy of Sciences. And he used to tell us about thought process. He brought up this thing, the Epicurean model of thought. And so he thought that when you were trying to solve, prove a theorem, very abstract, right? And you would sit there and have this experience of pounding your head on the table and getting very, very frustrated while you tried to figure out the problem. And often the best thing to do would be to work for a few hours and then go take a break, do something else, go to the bar, whatever. And maybe in the middle of sleeping that night, you'll wake up with this aha moment. And he viewed that as he called it the Epicurean model of thought. I have no idea if this is accurate, but it's a good model. While you're pounding your head on the table, you are taking relevant ideas off that pegboard in your brain and throwing them into a bingo pot, where, like the kinetic theory of gases, you get random connections of these ideas coming together. And when the right idea comes together by random, the power of the aesthetics of that beautiful solution are so powerful, they crash through to your conscious mind. So he gave us math exams. We only had 14 kids in the class because it was, who was a math major. And he would give us a piece of chalk and the chalkboard, and he'd tell us something to prove that was pretty easy, and we'd start writing on the board and doing it. As soon as he realized that we knew what we were doing, he said, enough of that, let's do this. And you knew you did well if you could never finish any of the things he asked you, because he could tell that you knew how to do it, so why waste the time? And he wanted to push you. And he'd eventually get you to a place where you had no idea what to do. And then he'd start to drop hints and see how we did with the hints. And when it was all done, because this was a very subjective exam, he gave us 2 grades. And those 2 grades were averaged for our final grade. And those 2 grades were how good was our conscious thinking, and the other grade was how good was our subconscious thinking, going back to this Epicurean model that he told us about. And that was where, he gave us hints, how could we synthesize those to crash through to our conscious mind to do the technical aspects of actually doing the proof. And so it was pretty amazing. But that took a lot of time. I mean, I was in there with him for over a half an hour. And, I got a C for my conscious thinking, but I got an A for my subconscious thinking. So I got a B for the exam. And I was pretty happy. But I learned a lot. It was an amazing experience, but it's just not scalable to 150 people. That's just too much time.
But there's that reminds me of one question from my PhD qualifying exam. And the question was very simple. You have a gas of charged particles. The box that the gas is in expands. Does the temperature go up or down? And so, of course, having done however many years of physics at that point, I went straight to the nuclear option. I'm like, I'm going to write the partition function for this thing because if I know that, I can calculate anything. So, I go through the jumping through the hoops of writing down the states of the system, and I start to write integral of, and then I have this moment of, I'm never going to be able to do the math for this. This is completely intractable, what I've set myself up for. And one of the people on the committee saw me have that moment where I had finally realized that, integrating this by hand was not the correct approach. And he says, okay, good. So now just think about it physically. Where is the energy in the system? And I'm like, oh, yeah, huh? And 5 minutes later, I was at the answer. But, it was just one of those experiences that sticks with you. I wish we could have more of our students to have more of those epiphanies on their exams instead of just grinding out written calculations.
And speaking of written, another option is to think more physically and have them actually write essays and write papers about the concepts that underlie it. And this used to be a pretty good way. Now, that also takes a lot of time to grade. That's not so easy. But the whole world has changed in the last year. First of all, now ChatGPT will help the students write those without necessarily showing that they understood it. But it will also let the instructor grade them more accurately. And maybe there's a way with the oral exam, if you record it, that we could transcribe it and grade it automatically. But unfortunately, you still have to sit there through the whole oral exam and participate in the interaction. So until ChatGPT voice models can actually do that interrogation on a curated set of data so it's accurate and be able to do assessment, this hasn't happened yet. Maybe it can. Maybe ChatGPT will finally give us a way to evaluate the quality of learning, but I think that's a long way off. But it's a nice thought. At any rate, so we've talked a lot about what's wrong with grading, what's wrong with exams, why, oral exams, which are great, really aren't scalable. But what do we do? Are there new methods out there? And when I say new methods, I've got to put that in quotes because there are, but they're really not that new. They've been around for a while. And so, for example, people talk a lot about mastery grading as one of these new things that we're going to do. But if you go back in the literature, the person who coined the phrase mastery learning and first wrote about it was none other than Benjamin Bloom, who's very famous for his Bloom's taxonomy back in the 60s. And so, but mastery grading is starting to gain a lot of traction. So why don't you tell us what you think mastery grading means?
Oh, interesting. So this is not something I use in my classes. We can get to that. But my understanding of mastery grading is that you have your course broken into many small components, and for each of those components, you're assessing the students almost on a binary scale of have you achieved a sufficient level of proficiency on this or have you not? And then by totaling how many course components students achieve mastery of over the course of the term, the quarter, semester, year, whatever it is, then you can assign a final grade based on how much of the course content they have mastered. Is that how you implement it in your classes?
Sort of, but I'd say that the K through 12 community has been using this for a long time, especially with the younger students. And so I know when my kids were going to school, they weren't getting grades until like after fourth grade or fifth grade. Until then, they were just getting one of three things: exceeds expectation, meets expectations, or is approaching expectations. Because the idea wasn't to stigmatize the student with something horrible, but rather talk about where they are relative to what the teachers wanted them to do, to give them flags so that they knew who to give more attention to. Because, our public school system doesn't have that much money. Teachers aren't paid that well, and most teachers find themselves in classes that are way too big for them to adequately teach. So they do a triage, and that's exactly what that is. Except unlike a triage, the worst group, they don't just leave to die. They actually spend more time on that worst group, a little more time with the people who are just starting to meet those expectations, and then maybe even enlist the help of those students who exceed to help the younger students do a little bit better. That's kind of the idea of the one-room schoolhouse, right? Where all grades used to be mixed together. The older students would help the younger students. And, it's a pretty powerful technique, and I think it works really well. So why don't we use that in higher education? That's kind of my thought on the whole thing.
Well, since you gave me the perfect launching point, I'll have to say that's very close to what I do in my classes. I am bringing together a few of the topics we covered today. Most of my assignments are scored on a 5-point scale because that's coarse enough that I can actually be reliable about it. I can distinguish between a 4 and a 5, a 4 and a 3. And my criteria are exactly what you've just stated. I have meets expectations, exceeds, does not meet, and then descriptive rubrics that say, here's what I'm expecting. If you achieve this, that's a 4. If you exceed that, that's a 5. And there is a lot of student angst around that, especially at the start of the semester. Oh my God, I got a 3 out of 5. I'm failing out of school. No, it means you're almost there. You're not quite there yet. And it's something that I find makes the grading go a lot smoother because I can focus on the qualitative feedback that I give to the students about where they succeeded and where they still need to develop more, as opposed to spending my effort trying to turn it into a number.
Right. And of course, by using rubrics, you're moving towards another form of mastery grading. You're probably doing something closer to specifications grading.
Yes, that's right. So I'm giving the specifications for what the different levels of achievement are for each assignment, and then just comparing what the students produce to those specifications.
So you've put in a lot of transparency to your grading, even though the students may be fearful because it's new. It's actually a lot less opaque than just, getting a percentage on an exam where then the professor arbitrarily draws the lines later on. There's no transparency to that. So that's pretty cool. And then there's another movement that has grown up around mastery grading, specifications grading, and there was a book published that talks about this quite a bit, and it's called Ungrading. And the ungrading movement is also not a new idea. For example, the president of University of Chicago decided that grades were evil back in the 1930s, and he banned grades. But that only lasted for about a year before they threw the guy out because none of the faculty could deal with it. But the truth is that if you go way back, grades didn't exist until the late 1800s. And they were started in England at Cambridge and Oxford, not grades, but levels, right? You achieve some level. And do you know where grades were, A, B, C, D, were first instituted in the United States and the whole world?
I don't.
This is
I would
according to
guess
that
University
book.
of Chicago, just for pure irony.
No, for real irony, it started at the University of Michigan.
Oh, no.
Yes.
So we were the leaders there as well.
Yes, we were. And it caught on like wildfire. And at least that's what the book on grading says. I will trust them. It's a fascinating book. And so this whole ungrading movement is to get rid of all of those concepts. And if you take it to its logical conclusion, the logical conclusion of ungrading means you don't give grades. And instead, you just ask the students, what do you think you deserve? And it's kind of interesting because, that will actually work sometimes, but not at the University of Michigan. And I watched a podcast that Eric Mazur did on ungrading with two faculty members from the Eastern Kentucky University, which has a very different demographic than Michigan or Harvard. And they actually talked about their students. When they let their students give themselves grades, they almost always give themselves a lower grade than they actually deserved. But that's because they have mostly non-traditional students who, are mostly first-generation college students. They know why they're in school, and they're pretty tough on themselves. And with a great comment, one of the faculty members said, "But this must be great at Harvard. Your students are like so highly evolved." And Eric just shook his head and said, "No, think about how they got into Harvard. They all got in by focusing entirely on grades. And so there's a lot of dishonesty in that whole process. And sadly, University of Michigan is close to that. So it just won't work to let students give themselves grades because they'll just give themselves A's. I don't want to be that, cynical, but I'd say for 90% of the time, it will be cynical. So we can't quite go that route. It might work some places, but that to me is a bridge too far.
Yeah. As we're talking about students grading themselves and this sort of student obsession with the A, it really makes me think about the fact that there's a very wide gap between how important our students believe grades are and how important grades actually are not. That as we're sending students to their employers or to graduate schools, the large majority of what we're writing in our recommendations is not about the grades they got. It's about what they did and the interactions that they had. And right. Certainly when I'm writing a letter of recommendation, I'll say about 2 sentences of this student got an A, and then 2 pages about the actual human being, not the letter.
Right. That's right. And what's sweeping the country is this whole idea of holistic evaluation of admissions. And for the graduate programs, it's well known that all grades are, as a predictor, is whether or not students will score well in exams in graduate school. And it says nothing about how well they will do with research, which is what PhDs are all about. And for research, we know that we'd rather have a student who's perseveres, who's fearless, who embraces failure, learns from it, has grit, all these other things. We would much rather have a student who's overcome adversity in their undergraduate career to go from a pretty low level to a high level. That shows an ability to overcome the kind of barriers that are actually important for doing research, because that's what research is all about. Better get used to failing a lot and embracing it, because if we knew what the answer was, it wouldn't be called research. So,
right.
With all of that, I again, students have this, how do we educate students that grades aren't important when all of society is telling them that they are? And it's really, really sad. So anyway, we've talked a lot about some background about what you and I believe is important in grading or not important in grading. Why don't you tell me what you actually do for grading? You started by telling me you have a multi-point scale. Can you be a little more specific about how you do grading in your class right now?
Sure. Yeah, on the implementation side, for each of these assignments, whether it's a report or a lab notebook or a homework or... No, actually, I guess that's about it. The rubric will have a description of what students should be accomplishing in the assignment. So as a concrete example, in this last lab report that my students have just turned in, I'll have a line that says, for example, must compare predictions of a theoretical model to experimental data and evaluate the accuracy of the model. And then at that point, the different levels of grading are a 5 does an excellent job of providing a convincing explanation that combines multiple sources of data. And a 4 accurately compares the theoretical model to the experimental data, but does not bring in other sources of information. And there's this kind of tiered structure of what will really convince me that you know what you're doing, and then sort of taking away some of those pieces of the argument as you get to lower score levels. And an important distinction that I think is worth pointing out here is that I'm telling students what they need to have accomplished at the end of the day. I'm telling them here's what will convince me, but I'm not actually giving them a list of boxes to check, right? I'm not saying, okay, you have to get some error bars on this thing. And I'm not telling them, oh, yes, you should run the model with different model parameters to see whether there are numerical issues, because that's part of what's being assessed is, do they have the understanding of this process of science to be able to do a meaningful comparison? And sometimes students look at this rubric and they're like, so you want a meaningful comparison? What does that mean? But then that's a great question. That's something we can have a conversation about. And when they're ready to ask that question and we can talk about it, then that's a place where I think true learning can really happen. So I would argue that there's value in an interactive course, that leaving some things not fully written out explicitly in these specifications is good, because it gets students to question the meaning of the words in the specification to help them unpack any gaps in their own understanding of it.
Right. So I think it's important to mention that you teach a laboratory class, and
Yes.
that you typically have, you spend a lot of time with the students. So your teaching schedule is 4 days a week. Every afternoon, you're in the lab with groups of students, and you typically have groups of 4 in each team. Is that right?
Yeah, usually 3 to 4.
And how many teams do you have? Because you have them all rotating on stations around to utilize the equipment.
Yeah, typically a section will be 4 teams, and then I'll have however many sections I have based on enrollment, usually 3.
Right. So you have like up to 16 students at any given time. So you actually
Yes.
have time to interact with each student, because how long are your labs? Are like 2 hour
they're
labs?
4 hours.
4 hours, yeah. So you have
Yep.
you have a lot of time to interact with each student, and that just you just have to spend a lot of time. So in a way, you're able to do oral exams with all your students almost every day.
Yeah, I just don't call them that. And
That's right.
That takes away a lot of the stress around, oh my God, I'm being examined. No, we're just having a conversation so I can see what you get and what you don't get, so I can help you get what you don't yet get.
Right. But
you know, this
again,
approach,
go on.
I was just going to say that this approach is going to hit a scaling limit where in a 120 person course, there's just no way to do this unless I had an army of grad students who were all trained in pedagogy and able to tease out students' ideas in this same way. So that kind of leads to the question of, in a bigger class, because like Steve, your classes are significantly larger than mine.
Yeah.
What are other approaches that you can employ for grading that would work well with a larger number of students?
That's right. So I have 140 students in my class this term.
Wow.
We had 24 teams of 6 people per team, roughly. Some teams were 5 people. It was in a very large room. And so, I've tried to structure my course really around the way that I'm going to do grading. And so I think one thing that was really important in what you do, Tim, is a best practice that lots of people talk about, that if you're going to give assignments for a grade, it's better to give lots of low stakes assignments. So instead of giving 3 exams, it's better if you gave 14 exams that were all equally weighted, because that way, if you do poorly on one of them, it doesn't crash your whole grade. And so by working with them every single week and interacting with all of them, you've kind of created a large number of evaluations with low stakes for each one that conclude with your judgment, where you can use your rubric to grade them. And so I do try to do the same thing. So with as many students as I have, it's kind of hard to just redo everything. I have to do it in steps. So I looked at what I had been doing. So I give reading assignments for every class session. And I give, we usually have, I meet 2 hours twice a week. And so each week has 2 class sessions. And so I usually give 2 reading assignments for each class session. Each week, I have a homework assignment. Each week, not the same week, but I have what I call a readiness assurance activity, which is a more formative-based test, but it's weighted heavily towards the team participation. I also have outcomes assessment reflections, where at the end of every module, I have students reflect on what they actually learned. So again, my whole course is set up to focus on retention, because I think that's really important. And one way to get retention is to have students revisit a concept multiple times over a relatively long period of time. So all of my modules, so a module starts with a 1-week effort, and that module then extends for 3 weeks before they actually finish all the things. So while they're working on other aspects of that module, a new module is being initiated the next week. At any rate, I have roughly 24 reading assignments in the term. We have about 12 weeks, 14 weeks, something like that. So I have, 24 reading assignments. I have 14 homework assignments. I have 14 readiness assurance assignments. I have 14 outcomes reflection assignments. And then I also do projects. And I've been doing 3 projects, but the first one's just for practice. I'll be changing that next year, mostly because drop add deadlines destroy teams in my class for the first 3 weeks. So my first project has pretty much always been a bust because the teams got disrupted so much it wasn't working. But I finally figured out how to fix that. I can now go in the day after class starts and drop the enrollment number, so nobody can join the class. People can still drop, but nobody can add my class after the deadline. And that's going to let me have 3 projects, which will be worth 2 units each. When it's all said and done, I add those all up, and I have 72 units make up my course. And what I tell the students is they have to get an A on every single unit. Now, I'm a little flexible there. An A- is just as good as an A because I can't really distinguish. So they pretty much have to score like a 90%. But it's not a strict 90%. I just do it as a 0, 1, or 2. And a 2 is an A. A 1 is approaching expectations. And a 0 means they just didn't do it. And I try to give each of those units where I can. I can't always do it. Where I can, I give them the ability to retake them multiple times until they achieve a 2. All the reading assignments, which are 24 out of 72, a big chunk, all of that are reading assignments on Perusall. And Perusall gives me the ability to allow them to continually add annotations that score highly, or to do high quality interactions so they get credit for being social, because I believe social learning is a powerful tool. Social learning is hard baked into our DNA. Writing's only been around for 5,000 years. Social learning's been around for 3 million years. That's our primal instinct. That's how we learn. And so by being social, by interacting with other students on Perusall, I really highly value that. So they can do that up till a deadline. They, once the deadline goes, too late. So that's how I'm trying to do mastery grading. I also have these reflections. So what I grade is the homework reflection. I don't grade the initial homework effort. I only grade that on effort, not on accuracy. They have to scan their work and put it into Canvas. They have to do it. But I pretty much just, virtually weigh the packet of information to see that they tried. And that's just a check mark. They have to do that if they want to get an A on the assignment or pass that unit. If they don't do that, it doesn't matter what they do later on. They're not going to pass it. Then they have a homework activity in class where they make a better homework solution with their team. And I hire all of these instructional aides, our senior level material students who were just in that class 2 years earlier. And so I have one undergrad for every 2 tables, maybe every 3 tables, and they walk around and provide help. But it turns out the students don't really need help. The help they need is those students that are introverts and don't talk need to talk. So I tell the whole class we're going to do this, and I train the instructional aides to pull those folks aside and say, hey, Johnny, you're not talking enough. How is anyone on your team realize that you're adding value? And unless they realize you're adding value, they won't respect you. And good teams are teams that respect each other. So we help the introverts become less introverted. We also talk to the extroverts and explain how important learning how to listen is. And it's sort of like in audio. We do compression on the high end, and we do, we boost the levels on the low end to try to make teams that perform better. Because ultimately, they need to teach each other these concepts if they want to have retention. So that's what I focus on. And does it work? Well, I'm not there yet. I still have a lot of problems with it, but I'm getting there, and I'm learning. Right now, I have way too many A's. So although I want to have everyone get an A, I know in my heart that a lot of students are getting A's who really don't know anything. And how do I know that? Because when I walk around the classroom, I will pick out a few activities that I give them that I know are very conceptual. And I go and make them write stuff on the whiteboard. And I talk to every single team. It takes me about a half an hour to get around the whole room. But I can get a really good feel for whether they learned anything from their reading, whether they learned anything from what I talk about. And sadly, sometimes I walk around the room like I tried to tell them with extrinsic semiconductivity, where the acceptor level is, where the donor level is, where the Fermi level is for an intrinsic semiconductor, and where it moves when you have an extrinsic or, an acceptor or donor. And I try to get them to draw these pictures on the board. And then 2 days later, I give them that exact problem on the readiness assurance activity. And on the individual round, 30% get it right. So I failed. I thought I was giving them one-on-one instruction. I thought they understood what I was saying. But other factors always come in. This was on the second to last day of class. And I'm sorry, students, by the time they hit the very last week of the term, are pretty much brain dead because their other classes are weighing so heavily on them. They're cramming like crazy. And it's a really tough environment to learn something new that last week of class. So, we all suffer from this. I'm sure you've observed that phenomena as well.
Oh, sure.
And so those are my problems. But what I'm going to try to do next time, I'm going to go back to something that's really like an oral exam. It's called the Feynman technique. It's what Richard Feynman told all of us. If we want to know that we actually understand something, we should use the litmus test of, can you teach this to a 5-year-old? And if you can teach it to a 5-year-old, you probably really deeply understand it. And if you deeply understand anything, chances are you're going to retain that for a long time. So I'm going to play around with things like I do for my projects, which is whiteboard video. And I'm going to try to get students to make short whiteboard videos. My whiteboard videos for my projects are like 2 minutes long. I think for certain concepts that I'm going to ask them to do, I'm going to embody the idea of a YouTube short or a TikTok video. They have 30 to 45 seconds to teach the concept. And we'll see how that goes. I haven't quite figured out how to do it. But the truth is, they're all pretty skilled in editing video. They come to college knowing how to do that. So let's exploit those skills. Let's get stuff up. And maybe they can help each other enough. And as if I build a library of the good ones, those can even help students learn small little chunks. But we'll see.
Yeah, I love that idea of producing short form content. One trouble that I have in my course with the specifications that I'm using is students come in believing that more is better. And, maybe I'll just write 30 pages instead of 20, and then all the right answers will be in there somewhere. And they will, but that's not really helping the underlying problem. So this is something that I'm always trying to find ways to do better in my classes, to give assignments that really have students distill something down to just the minimum essence of the concept or the problem of the calculation, and do it in a paragraph. Don't even do it in a page. If I could really get them to be more concise and to think about how short can I make my product instead of how long can I make it, that would serve all of us very well. But yeah, we'll get there someday.
We all know it's much harder to write something that's short than something that's long. And
yes.
The same is true for video or anything else. The thing I like about video is that it's way ahead of where ChatGPT can quite get to right now. It can start to make videos, but they're not going to be very good. And so I don't have a problem with having the students use ChatGPT to make their script, but to make the script and make it concise enough for a 30-second spot, that's a pretty challenging thing. That requires you actually think about what ChatGPT is telling you. And as long as you think about it, that's a really good activity in my book. Because once you've thought about it, you've gone beyond just memorizing. And you've edited what ChatGPT says. And so then ChatGPT becomes a tool. And it's a useful tool, but you must edit it. You must think about what it's saying in order to make something very concise. So I think that's a good strategy.
Yep. Evaluate whether it's accurate, decide how it can be done better, and then actually execute the doing it better. And that's a really good use of time for learning.
And I'm even thinking maybe I can come up with an activity where they use their short form video to teach other people on their team and have the other people on the team evaluate the quality of those videos. So we'll see. Not sure how I'm going to pull this all off, but that's what I'm thinking about for next year. What are you thinking about for next year?
I'm thinking about the biggest change that I want to make on this topic of grading is doing a better job of mapping this 5-point scale onto a numerical scale that will make sense to students who have grown up in 0 to 100 land without getting to this compression problem that you were bringing up at the beginning. If I can actually spread out the individual numbers over a wider numerical range so that the values are distinct and have separate meanings from each other without getting students into the panic of why do I have a C- territory, that's really what I'm focused on right now is to help students distinguish the score on the assignment from the grade you're going to get in the course.
Right.
Because as much as I would like to just tell them that grades don't matter and have them actually believe it, that's an impossible challenge.
Yes.
So have to work with what our students believe instead of what we wish they believed.
Well, that's a good point to end with. I think we've been talking for a long time now, longer than we intended.
It sure is hard to be concise.
Yes, it is, especially when it comes to something as intractable as grading. So
Yeah.
I guess with that, we'll say goodbye and looking forward to our next chat, Tim. See you later.
Okay. See you next time.